All right, so my name is Arup Guha. I am one of the coaches at the University of Central Florida, and full-time I'm an instructor in the computer science department. I typically teach 3 or 4 courses a semester, and I teach a competitive programming class for students who are not on the team. And I ran a little experiment this past semester in the spring of 25, and so I thought it would be appropriate for this talk. All right, so let's talk a little bit about the course. Officially, the title is called Team Dynamics, COP 4516. All right, and we offer this course for students who are not on the programming team. So kind of the training for our team is a little bit different. This is more of a regular course where students get a grade, and I have to, put together a syllabus, 5% this, 10% that, and so on. We run the first 7 Fridays. We do a 3-hour competition with 4 questions each. Usually, one of the questions is pretty easy. A couple of the questions are based on the lecture that I gave earlier in the week. And one question is just sort of random. You know how in real contests, you don't know what to expect. So I like giving them just a tiny bit of that flavor instead of just, exactly a test of what I lectured on. All right. So, a lot of people have been talking about AI. And in fact, I was up in New York about a year ago, and Christian and I were talking about this. And he was wondering, well, how useful is it? How much better will students do if they have access to ChatGPT or some other AI model? And I said, hey, I'm teaching this class in the spring. Maybe, I'll just run a tiny experiment and we'll find something out. So here's what I did. I split the class into 2 groups randomly. There's about 50 to 55 students in the class. So, in between 25 and 30 students a group. And then I picked just 2 out of those 7 contests. So 5 of the contests I ran regularly, as I've always done, taught this course for about 12 years. And then for 2 of the contests, I had group 1 use AI in the contest number 1, and then the other half of the class did it regularly. And then in contest number 2, I had group 2 use the AI and group 1 compete regularly. And so some questions that I had was, okay, so in contest 1, let's just look at the scores between the 2 different groups. How much did ChatGPT, and again, students did use other AI models, but how much did it help? And then same thing, in contest 2, did it help equally? And then I wanted to look at individuals, right? Did it help each individual the same? Did each individual improve by 1 problem? Or did some individuals improve and some individuals not improve? And then most importantly, mostly what I was looking for was qualitative feedback. So I actually took out one assignment I typically have in the class, and I inserted an assignment for 5% of the course grade where they just gave me feedback. They wrote feedback about the experiment itself. So in terms of making the groups, how did I do that? So it turns out that the registrar office helped me out nicely on this one. The labs that we run aren't big enough, so the students have to randomly register for 1 or 2 labs. And so I just use those room assignments because we have different proctors in different rooms, and I thought it'd be much easier to sort of enforce the AI, no AI rule. So I just use the room assignments. And just to make sure that it was a reasonably fair breakdown, not that like all the smart kids were in group 1 or all the smart kids were in group 2, I looked at the non-ChatGPT performance, so how well they did on those other 5 contests. And in group 1, out of the 4 questions, they got 2.12 questions correctly per contest. And in group 2 is 2.14. So I'm not a statistician, but those look pretty darn close to me. So my conclusion was the way these groups were split, it was fairly even in terms of ability. And I'm actually going to share the questions. We have 30 minutes here, right? So some of these are questions from old competitions. Some of these are just questions I made up. Kind of varies. So ground game is a very easy string problem. You just read a strings of arrows. 1 arrow means going up, 1 arrow means going down, 1 means going to the right, 1 means going to the left. And we want to know what's the furthest down I ever went, right? So you ignore the left and right arrows. You just count the up and down arrows and you find them in. There's a problem called dot game. And I don't know if you've ever played agar.io. I don't usually play video games, but it's like where you're a dot running around and you eat the smaller dots and the bigger dot kills you. And so the question essentially was, I made some rule up for how much bigger you get when you eat a dot. What's the fewest number of dots I need to eat to be the biggest dot on the screen? So, you need to use a priority queue so that you eat, the dot that is slightly smaller than you. And then, there's different ways to do it, but a data structure type question. Tree sales was a company problem where we have bosses who have a bunch of people under them, and we're keeping track of some sales. But instead of doing it like top down, you have to do it bottom up, and you have to store something extra in a node. So you don't have to do any sort of crazy segment tree sort of thing, but you have to sort of make a tiny adjustment of what you store in the node, and then otherwise you can write your usual sort of regular tree code. And then finally, lottery. I did not write this question, but one of our college kids did for our high school contest. And you have to use 2 tries. You store everyone's name forward and everyone's name backward. So the reason I spent time explaining this is so you understand kind of the level of the questions, because I think in terms of understanding how much ChatGPT helped, this was, to me, a very relevant topic. All right, in contest 2, same letters, as actually a question from an old regional from North America. And it's just, hey, you're given 2 strings, are they anagrams of each other? The second one, interstellar love, roughly comes down to counting the number of components in an undirected graph. The third one, maze, is a fairly straightforward breadth-first search on a grid. So you start at some spot, and you need to get out of the grid, and there's some block spots. And they're nothing special. You can't jump or anything like that. It's it was originally a homework question for one of my classes. And finally, the 8 puzzle. I should have made a picture of the 8 puzzle, but it's a 3x3 grid, and one of the squares is missing, and you have to slide the tiles around, and you have to get the puzzle all the way to the 1, 2, 3, 4, 5, 6, 7, 8. You got to get the puzzle looking exactly like so, and then you want to do it in as few moves as possible. The funny thing about that question is it's a tiny little detail, but in the input section it says, oh, there's 10,000 cases, right? So if you run a BFS on all 10,000 of them separately, it's going to time limit exceed, because there's about I think 180,000 positions that are reachable or something like that. And so the trick on that one is that you start with a solution and you BFS out to all the potential starting boards. And it's the same number of moves, so you just calculate it once, and then you can answer all 10,000 queries. So again, this detail comes up to be pretty important, and that's why I'm mentioning it. All right, so let's look at the contest results. For contest number 1, the control group was the group that was not using AI. They solved 1.8 problems in the 3 hours. The average rank, so I don't know how useful average rank is, but I think it's useful, because all I care about is where my team ranks in the scoreboard. So I decided it was worth calculating. 28.6, and there's, like I said, about 50 kids in the class. And then the average time to the first solve was 39.5 minutes. For the group that was using generative AI, 2.2 problems solved, so they did better, as expected. Their average rank was better, to 23.3. Interesting, fact that, at least for this particular contest, they actually took longer to get the first question. 66.5 was the average time their first submission came in, which I was quite surprised about. In the second contest, the second contest is maybe more what you would expect. The control group, 1.5. The AI group, 2.4. The average rank of the students in the control group, way lower, 39.5 versus 16.5. And then the average time to solve, again, this time the control group took longer, 63.7, and the AI group took 32.6. All right, so then I went to individual students. So group 1, this was the group that had the first contest where they were allowed to use the AI and not the second one. 2 students actually did worse. They got 1 fewer question than they did the following week. 11 students stayed the same. 6 students got 1 more question with the use of AI. 3 students got 2 more questions. And 2 students got a full 3 more questions. And then in group 2, you'll notice it's a little bit different. And obviously from that first table that I previously showed, you would expect this. But only 1 student did worse in group 2 when they used AI. 4 students stayed the same. 5 students got 1 question more. 9 students got 2 questions more. And 6 students got 3 questions more. So you can see it's all over the place. I was surprised that I had to put 5 rows on this table, right? I thought there'd be fewer unique outcomes, right? But it's all over the place. So some people it hurt, some people it helped, and some people it helped them like an insane amount. So some basic findings. I did not expect the differences between contest 1 and contest 2. So essentially, I think what I learned was that ChatGPT and AI in general, they're definitely way better at certain types of questions than other types of questions. So in that second contest, I had traditional graph algorithms, just run a straight BFS. It's really good at things like that, right? But for some reason, it had a lot of trouble with this lottery problem, and maybe it has to do with the wording of the lottery problem or whatnot. I'm not sure. But it had a lot of trouble with some of the problems from the first contest. You'll notice the way I asked the students about this, and kind of what I found out, is that if the easiest question is really easy, they're already trained at finding the banger in the set, finding it and typing it. So when they weren't concerned about typing something into ChatGPT, they got it pretty quickly. Now, the students that make it here would get that question in like 1 minute, but this is my regular undergrads, right? And so that's why that ground game question was so easy that people took, in the experimental group, they took a while to get to it, you know? Whereas when they weren't using AI, that was their instinct immediately. Boom, find that easy question. Look how many students didn't really see any improvement or got worse. 24 out of 49. So it's like half and half, right? Maybe not exactly what I was expecting. When we get to the student comments, maybe we'll understand that a little bit more. One thing I also wanted to see was who gained the most. I expected the people, those 2s and 3s, I expected them to be kind of the students who had the lowest grades in the course. But they actually weren't. They were obviously not the top students, but they were kind of a smattering all over, right? And again, this goes to a little bit of, you know, there's really 2 parts to this. One, what is the AI good at? But also, some students know how to use AI and some students don't. And that's kind of what that 4th sort of bullet really kind of gets at there. And exactly that last bullet is what I've found out, certainly. Currently, maybe one day everyone's going to be really good at using AI, but there's a huge variation of skill. Some kids were extremely skilled. There was one kid who, you know, he'd struggled in the class until this point, and then, I kid you not, he would do 3 hours, get either 0 or 1 problem. He finished all 4 when he had the AI in like 35 minutes. Like, he was extremely skilled at knowing how to prompt. All right, so the reason I brought this paper here is I can't memorize a ton of student comments. I've got a couple summaries here, but I definitely wanted to share, that's what I've got sort of jotted down here in more detail, some of the things that students said. So one thing that I didn't necessarily think about, but they pointed out to me, is that running this contest had a huge effect on their motivation. One kid said, hey, I studied for the regular contest because I had to, but what's the point in studying for the ChatGPT contest? Because I'm just going to tell ChatGPT to do stuff. So it already affected, so some kids study, you know, 2 or 3 hours before the Friday so that they can do well on Friday. But then when you put them or you tell them, hey, you can use the AI, they stop studying. So that was kind of it has that big effect on student motivation. Secondly, one student said, which I think another student said, hey, you know, it's not really quite as rewarding. Like, you know, I really enjoy solving these problems. I feel like that, you know, you kind of get that elation, that buzz when you finally figure something out when it clicks in your head. He's like, you know, I got them, but it wasn't fun. I didn't feel that same high that I get when I genuinely solve a problem on my own. On the positive side, one student said that ChatGPT helped me understand what the question was asking, and because it helped me, then I got more motivated, and then I actually made more progress, right? So the student actually would ask Chat to help explain in different words what, you know, a particular portion of the problem statement meant. So I thought that was kind of interesting as well. Okay, so now let's talk a little bit sort of the student comments in terms of the critique of the performance of AI. And like I said, the vast majority of the students did use ChatGPT. So this was kind of a consistent comment I got from quite a few students. It was awesome if it got it on the first try. If I just put it in, submit it, AC, it was awesome. But if I don't get that AC, it was really quite frustrating. It doubles down on its wrong approach sometimes. You know, one of the students said something pretty funny. It's like, yeah, it's really annoying because it doubles down on its approach and it keeps on doing wrong things. And then he says, comma, but this is exactly what I do, which I thought was pretty funny. Um, and then, but another student on the other side of it said, occasionally it caught its errors when I asked it to make its own test cases. So the student would prompt it, hey, can you make some data for this problem? And then it would feed the data back to it, and then it would fix its own problem. So I thought that was kind of interesting. And I have to share this, in terms of getting stuck in a loop or whatnot. On that 8 puzzle problem, because either the students didn't prompt it about the 10,000 cases, it wrote the regular BFS forward and would get a time limit exceeded. And so the student would prompt, many of the students would prompt back, hey, you got a TLE, make this faster. So then it would do some sort of heuristic thing that's super fast, but wrong. And we get a wrong answer. And the students would yell at it and say, no, now it's wrong. And what's funny is that it was actually able to, for a few students, it was able to get a heuristic solution, which I have no idea if it would always work, but it passed all the cases, right? So the AI was insistent, okay, you're telling me that old approach was TLE? Well, I'm going to find a way to get a heuristic to work on this guy. Some of the kids had 10 or 11 submissions on this problem. It was hysterical. But finally, somehow the AI found a sweet spot where and like I said, completely heuristic. I read the code going, what on earth is it doing? So I thought that was pretty interesting. The other thing about that problem that was interesting was there were a few students who got it really quickly in the AI, but they, in their prompt, told it, hey, run the BFS from the start state to the end state, and then you can answer all these. So the students had figured out sort of the portion of the problem that was sort of the problem deception and told the AI, hey, run this BFS the other way, and those students got it immediately. So that was kind of just another anecdote from that particular problem that I thought was pretty interesting. Some other quotes. It's less buggy than I imagined overall. It writes nice maintainable code for simple algorithms better than my own, but I still see value of doing it on my own. So the student accepted that it wrote better code than he did, but he was like, but I still understand why you want me to write this, which I thought was funny. Another student said, AI helped me the most by providing a structure of the code because, I read the problem and I wasn't quite sure how to structure the code, but it immediately gave me a structure. So instead of looking for a full solution, the student was just sort of looking for an outline to fill in and then was able to fill that in on some occasions. And then another student said, ChatGPT is scarily good at these types of problems. I'm not sure how I feel about it. So there, and then the last student, this is kind of interesting. One of the last students said, the latest model solved all 4 problems, but I didn't. So what I learned from this experiment is that ChatGPT, and sorry if any of the sponsors are here, but this is not my quote, it's from the student, is much better than Google Gemini by a landslide. This is, again, the student's words, not mine. All right, so now I want to talk a little bit about the downside, and Bill actually got to this. So many of the students actually, there's some students that use this stuff every day, but we have some really honest students who actually didn't know about it until I forced them to use it for the assignment. There are quite a few students who really weren't aware of its capabilities, right? They obviously they'd heard about it, but they chose not to use it. So the downside of running the experiment is now that I told all the students about it, all the students learned a little bit about how good it was or how bad it was. As you saw, the student comments varied. So I have a final individual contest, and in that contest it's a little different. On the regular 7 contests, the students can upsolve, and by upsolve I mean after the contest is over, they can, if they work hard and get the problem correct, I give them partial credit. So I give them 100% if they get the question in contest. I give them 80% if they get the question over the weekend without the data. And then I actually just post all my test data. So if a student can just download the test data and keep on working on it until they just get it, I give them 60%. But in the final individual contest, I run it I tell them, I want you to experience what a real contest is like. So I run it like a real contest, and there's no credit after the 3 hours. And my typical rules are you can use any printed materials. So the old school ICPC rules, bring in 2 boxes of books. No one does that. And I do let them look up the language API online. So I don't have any sort of, the class is not as serious. I just kind of walk around and make sure, they aren't doing more than that. And like I said, same as usual, but the course, it's worth more of the course grade because it's kind of like the main individual competition that they have. So it's worth 20% of the course grade. So turns out when things are worth more, students are willing to cheat more, right? And I ended up flagging 11 students for cheating. But exactly what Bill was talking about, it's very tricky to figure out whether or not people actually cheated, right? And I can talk a little bit more about this. I ended up finding out that of those 11 students, 8 of them had used AI during the competition, like when I wasn't looking or the TA wasn't looking, like just, because obviously you can look so many different places, right? They ended up using it. But like I said, not all 11. 3 of the students didn't use it. There was actually a student who pretty much produced identical code to the code that the AI produced, but he had notes with him, and he showed me that his data structures teacher had taught him that particular algorithm in what I thought was a weird way. I didn't realize that any of the other professors at our school were teaching it that way, but he had the notes, and he pulled it up on the web courses with the date from like 2023, and he had brought that with him to the competition, right? And so I found out, that's the hard part about this, is that I ultimately ended up interviewing all 11 students. All 11 students got called to my office. I did a one-on-one interview. A bunch of them just admitted it immediately, right? But the ones who were adamant, it was 3 different situations in each case. That's just one of the situations that happened. So that was the tricky part about it, is that it promoted the cheating because the kids then knew about it. And then I had to spend like 11 up to 30-minute meetings. The ones where they admitted the cheating went shorter. But and what I did to just double check that students, to double check that the ones who didn't cheat, I actually gave them a new problem that tested the same concept, and I sat there and watched them, and I asked them as they were coding. And in fact, I was surprised by this, but there was one student who I'm pretty convinced didn't do his own work, but he thought he could get away with it, so he told me that he did. And then I said, okay, well, go ahead, here's the problem. And I was shocked at the difference between the other 2 students who coded it flawlessly and explained everything to me perfectly. A, half the code he wrote didn't make any sense. And B, he couldn't explain, and it was very obvious. But I was surprised that someone had the guts to do that when I told them exactly what I was going to do. Just own up to it. I thought that was kind of, I was surprised by that. Yeah, I guess so, right? So yeah, essentially the old method, I used to catch cheating much more easier. I would just search little snippets of code that look weird on the internet, and super easy, right? And then of course there are the cheating detecting programs. You run the nChoose2 programs that we talked about, right? Choose came up when Bill was talking. Run every pair and you can find, some similarities, right? But the problem is that the AI code isn't quite identical to online code. And then furthermore, what's really annoying is that legitimate code that students write sometimes looks exactly like the AI code, but the students actually did it. So now you've got both issues here. And like I said, basically I had to interview each student, and I did a live coding exercise. Very time consuming. It was a very busy week because I had to do all my other stuff that week too. But I wanted to figure out what was going on. It was important to me, so I put that time in. Anyway, thank you very much. There's a little picture of my family from one of our summer vacations this past summer. And if you do have any questions, there's my email, dmarino@ucf.edu. So I would be happy to take any questions. Yes, Etienne.
Oh, I've got so many questions. But thank you.
Oh,
so, hello? Hello? Hello?
Is there a button? Yes, green up to the top left.
Is that working now? No. Hello. This one works. Okay. Did you try, or it would be interesting for you to try a third group of students where before the programming contest, you give them some advice of how to effectively use ChatGPT. For example, instead of trying to have it just solve the problem outright, tell them, oh, other students have found it useful to have it help you generate test cases, or to write an outline for the problem, or to help you debug if you're getting wrong answer, find out what's wrong with it. And I'd be curious if with some guidance of how to effectively use the tools, it becomes much more useful to them than if you just let them use it however they feel like.
That sounds like a cool idea. Maybe I'll do it in spring 26.
My other suggestion is that it's not surprising to me that AI helps on one particular contest where the AI is being used, but I'm wondering if it helps, if training with AI then helps you on contests where you're not allowed to use the AI in the future, right?
Oh, that's an interesting question, yeah.
Kind of like with engines in chess. Like, of course, we know that the engines can beat any human at chess, but is training with an engine going to help you as a chess player when you're playing human to human later, right? And is something similar true about competitive programming?
Yeah, I think that's a really interesting question for sure. You know, it's interesting. What I find, I have a couple random comments that I'll share about that. Is I do find that I feel like if you use those tools to learn and you care about the learning, it will probably help you learn better. But I found in my general student population, because they primarily say, and my TAs tell me that almost no one comes to office hours, so that a lot more students are now attempting to study for exams that way. And I have found a small but significant, about 4 or 5% drop consistently over the last year in my exam scores. And I feel like sometimes what happens is that students, when it just spits out an answer, they don't process it the same way as even when they look something up on the internet and then try to replicate it, say, in their, in their code or something. But yes, that would be, again, really interesting to see how that we can use it effectively. And I think if the student cares, maybe it will be very helpful. Yes, Christian.
Yeah, so I guess maybe two questions, but in terms of the ChatGPT or Gemini or Cloudian, etc., was there like a limitation on what they can use? Most people will probably use free version, but paid version is much better. So, was there variations of the versions they use?
Yeah, and I should have asked that question, but I didn't. But one of the questions I didn't ask on the qualitative feedback was which specific version you used. I suspect most people use the free version, but I bet you a few people might have used paid versions.
Sure.
But I unfortunately didn't collect that.
Right. And then maybe a second question, I probably can talk about it after party, but it's really about the question itself, right? So what I know is actually the style of the questions. I mean, if they're copying and pasting the actual prompts, and then put it as a context, then the question, like how it's written, makes a huge difference in the actual responses, right? And what they say in the question itself, right? Can you explicitly write the code in Python or C++ or etc., or can you guide me? And then students will do some iterations of that. So I'm just wondering about perhaps was there some obfuscation of the problem statement purposefully to find out whether there's variation?
So these were all old problems, so they weren't written for the purpose of seeing, can we obfuscate the AI? Because most of them are several years old. I do know that some people just took a picture and fed it in that way. Other people summarized it, and other students, and they said in their longer write-ups, but other students, they just wanted a portion of the problem solved, so they said, please write me a function that takes in this, and the graph is stored they had paraphrased in their own words some small portion of the code that they wanted. So it was it varied, and then I think just naturally, yes, some of the questions are probably obfuscated a little bit more just based on how they were worded. One of them was an official regional question, whereas one of them was just a random question I made up. Another one was for our high school programming competition. So kind of the level of writing probably did vary some.
Right, because I mean, for example, like a CSCS, I'm sure is like a cookie cutter problems, whereas a very small problem statement versus some really long one with some, like records of things, and then the problem statement actually begins, and these things, I'm sure they make at least marginal difference or more.
Yeah,
right?
yeah. All right. Any other? Oh, yeah, go ahead. You have a mic.
Thank you, Arup. My question was about the control group. As you found in your exam, 20% of the students were cheating in the exam. Presumably some were cheating in the control group as well, right?
I don't know. Yeah, maybe. I have no idea. I mean, yes.
Especially because if there's upsolving, then it's open season, right? So then I would be hesitant to say that this is actually a measurement of the students without ChatGPT. I can guarantee many of them will have been using ChatGPT, right?
Yeah, I mean, what I will tell you is that the number, because you would feel that there'd be a lot more like total solves, but I compare the like who solves like all 4 questions to past years, and so not everything, but because they have the upsolving, they lose almost nothing in grade, right? So whereas in that final individual contest, it was either a 0 or 100, you know, and it was multiplied by times 4, like how much it was worth for the total class. So like the effect was much larger on their grade. So that's why I do actually believe that the control group in this didn't cheat, because it has almost no effect on their grade.
Okay, this is not my experience. My experience is that students cheat on everything, and no matter how little it's worth. And this is found consistently in literature, but I hope you're right.
Okay.
Yeah. I think Stephen also had a question.
When did you run this experiment, to be precise? Which ChatGPT version that your student used?
It was on, I had the dates on there. I think it was like mid-February
February
of 25 this year.
20.
Yeah.
And which GPT version was
Whatever they got online for free.
for free?
Yeah, I think some people might have had the paid one, but I think most of the students that choose to take this class actually probably don't have the paid one. So probably the majority of them use the free version is my guess.
Okay. My experience is GPT and Gemini and DeepSeek, they are all have a getting better over time. So if you repeat this experiment one more time, maybe in your next academic year, you will get different results.
Different results, okay.
Different results.
Yeah.
Like GPT, the AI will solve easy, medium, maybe some of the hard questions, I don't know.
Okay.
Yeah. One last question from me. Will you run this repeat experiment in your next iteration?
Yeah, I'll give it a shot. It sounds like you guys have enough ideas. I've gotten so many ideas from you all that I'm interested in doing it again.
Okay, thank you.
So from me, I'm interested in the differences between the experiments, like especially the time for the first to solve. I think it was that's very different in the 2 experiments. And you mentioned one possibility that it's because of the problems, like some problems might be easier for ChatGPT. But did you like investigate a possibility that some trends might influence the results? Like probably it wasn't like very controlled conditions of a competition, so you cannot help if you see everybody else in the room instantly opening ChatGPT. You might also do the same, and if you see everybody else firstly trying by themselves to solve the problems, you might also do the same. So did you like investigate the possibility that it somehow influenced the results of the experiments?
So the way that I ran it, as I discussed, everyone in a room was using AI, or no one in the room was using AI. So in the same room, I never had people where it was some people using AI and some people not. That's what helped us keep it straight because of how the registrar split the rooms. So there could have been a scoreboard effect, but I asked the students, and I think what happened is the anagram question was the easiest question on the second contest, and that's harder than just counting arrows that go up and down. To us, those both sound very easy, but for regular UCF students, there's a huge difference in difficulty between those two. But they were the easiest contests in both questions. So what happened was that the arrow one, students got fast, and so that average number was pretty low for the students who like looked at it and coded it from scratch. The anagram one was harder for the students who coded it from scratch, to the tune of what you saw. Like it took them a little bit more than an hour on average to solve that. Obviously, for the AI got those questions very fast, but the question was how long it took the students to give the problem to the AI, right? So that the arrow question, what happened was that group, they were too busy reading the problems and trying to give them, they didn't give the problems to the AI in the order of difficulty. Does that make sense? Yeah, and so that's why they were taking so long to figure out how to prompt the AI that their first solve came in much later. Okay, so
Yeah, you have two groups. One group that first uses AI and then no AI, and one group that first tries their own and then with AI. Well, do you, in your case, the group that first didn't use AI had better average score than the second group, if you match both cases? Do you
Yes.
believe that the reason this happened is that they first trained without using AI? Because from my experience, some people, when they train the hard way, they are even better in most cases, in both cases. But if they train in the easy mode, they expect the easy mode and they are not able to.
I suppose that could be the case, but we'd already been running the class for like 4 weeks, so everyone had been not using it and studying for a while. So I don't think that's why that happened. It could be that the students who got to use the AI in the second week, they knew they were using it, so they practiced using the AI, whereas the students who got to use the AI in the first week, they're like too busy doing other stuff and didn't think to practice using it. Maybe that's possible, but from what the students told me in their qualitative write-ups, it definitively was just better at solving the problems on the second contest than the first contest, because they described which ones it got, how quickly it got them, how much time it took to like fix them, kept keeping on prompting it to change things. So it seemed like from the qualitative responses that the real reason was that just the questions I happened to choose for the second contest were better suited for whichever AIs they were using. Go ahead.
Yep. Hey, Arup. Thank you so much for sharing all these details. And especially, I like your statistics about usage of AI. But from what I saw and most of the people asked, you kind of let those people to use GPT-3 or 3.5, something like this. And they kind of, overall, we have the same results, right? And the GPT, the older versions doesn't have that capability to understand like a complex problems, but we do know that a lot of large companies invest a lot of money on this, and we see like GPT-4, GPT-5 is growing, like they can probably solve complex problems. What would be your reaction when AI can reach to that level that it can outsolve the problems? And that's the first question.
Okay.
And out of your answer, I will ask the second question.
Okay. I mean, I still think it's useful to learn how to think and how to solve problems. So I think it's going to be really hard for school because there are going to be a lot of people who don't want to do that. Like, you're going to have to, it's like chess, right? Like now, I guess, computers can beat probably almost any human in chess, but there's still lots of people who enjoy chess and who spend a lot of time trying to get better at it. So I think that there will still be students who want to learn how these things work. And I think also that at some point, you do have to double check that what the AI has done is correct. But how do you build those skills? Because debugging it is not easy. And so I think it is important to build the skills. And I think ultimately what's probably going to happen is our program isn't going to be as big. I think we saw our CS program shrink some. So I think it'll shrink further. But I think that the people who end up doing it 10 years from now are going to really want to learn exactly how these things work. I hope.
Yep. And your answer kind of reached to that thing that I need to ask the second question. And yesterday there was a brilliant speech from Redwoosh, Mateusz, about how not copying and being inspiring about the ideas, about the algorithms can level up you. And when you solve a lot of problems and you can grow up, I kind of have this thing on my mind. Some people who doesn't know, for example, binary search. What is the difference between I put the less or less than equal? And it asks AI, okay, and it solves the problem, but they don't have that capability to think why it works like this, why AI solved it in this way. Or also, Mateusz just mentioned that there are other ways to solve the problem. Wouldn't you think that it can kill creativity of talented people when they rely fully on AI? and that restricts them to reach to the next level. They are not using AI, for example, to learn the things and polish their skills, but instead they just delegate so AI can somehow resolve these complex problems.
Yeah, I think I agree with you that if you just start letting it solve the problems, you'll reduce how often you are creative, or how often you like exercise your brain and try out different ideas on your own. So yeah, it is definitely what you're mentioning is something that I am absolutely worried about, for sure.
Because what you mentioned a little bit ago, that some students can use it in order to understand some of the complex algorithms, because we do know that not all the people have teachers who can explain them some of the paths that why it can be solved in this particular way. There are complex problems that can use multiple algorithms, so AI can explain it to you. Okay, that's a really good thing to have, because you can ask AI and seek for other ways to understand and train yourself so you can solve other complex problems. But it creates another problem that some people can fool themselves just to use AI to solve the problem, and that's it. They just don't understand that.
Right, they don't take the effort or time afterwards to understand. And I think ultimately with all technology that's true, right? It can be used in many different ways. And then ultimately it's probably just up to the individuals how they choose to use it.